Now let's talk about what you'll learn in this class in terms of principles and techniques. So this course has 3 goals: to prepare students, to enable the students, and to empower the students. Let's go through the 3 goals. So the first is to prepare students for advanced Berkeley courses in data management, machine learning, and statistics by providing them with the necessary foundation and context. Now we know not all of you will be continuing on here at Berkeley. You may be graduating seniors, you may not take one of these courses, but we want to give you the foundation for being able to take one of those courses in the future. Maybe you'll take it through extension or online or through some other format. But the key thing is we'll make sure you're prepared. The second goal is to enable students to start careers as data scientists by providing you with experience working with real-world data, real-world tools, and real-world techniques. And when we say real, we mean actual real data. We mean actual tools that you would be using as a data scientist out in the commercial marketplace. And you'll use the same techniques that data scientists use in the real world. The third goal is to empower students to apply computational and inferential thinking to address real-world problems. And again, we'll do this by giving you actual real-world problems so that you can think through how to apply those computational tools and that inferential thinking to get the right answer. Now, some of the topics that we're going to cover in Data 100 include the Pandas and NumPy modules, relational databases and SQL, the query language for working with relational data, exploratory data analysis, so digging in and dealing with real-world data, regular expressions for processing data, visualization libraries like Matplotlib and Seaborn, sampling techniques, probability and random variables, model design and loss formulation techniques, linear regression, feature engineering techniques, regularization, bias variance trade-off, and cross-validation techniques and approaches, gradient descent and logistic regression, decision trees and random forests, principal components analysis, and clustering techniques. And you'll use lots of tools: Matplotlib, scikit-learn, Plotly, SciPy, Jupyter, Pandas, NumPy, Seaborn, and MySQL, just to name a few of them. Many more also. So this class officially has the following prerequisites. You've completed Data 8, you've completed either CS61A or CS88, and you're co-enrolled in EE16A or Math 54 or Stat 89A. Now, we do not strictly enforce these prerequisites. However, we're also not going to teach any of the material from those courses. So we're not going to teach you how to use Python or how to use Jupyter Notebooks or inference that's covered in Data 8 or basic linear algebra. So Homework 1 and Lab 1 will help you calibrate your background and whether you need to backfill on some of the material. For Homework 1, in particular, the Data 8 textbook will be very helpful to you.